topic for this lesson is light, reflection and refraction. Let's begin with curved mirrors. A curved mirror is a mirror with a curved reflecting surface, and they may be either convex or concave mirrors, and they would be a part of a sphere. So we said that there are two types of spherical mirrors, concave and convex. Now let's consider a sphere which is concave and another sphere which is convex. For a concave sphere, the inner surface would be smooth and polished and the outer surface would be rough. Whereas for a convex sphere, the inner surface would be rough and the outer surface would be smooth and polished. Now let C be the center of both these spheres and let R be the radius. Reflection would always take place from smooth polished surfaces. So in the case of a concave sphere, reflection would be taking place from the inner surface. Whereas in the case of a convex sphere, reflection would be taking place from the outer surface. Now let's consider these as two incident light rays incident on the inner surface of the concave sphere. Now these light rays would be getting reflected. Similarly, light rays incident on the outer surface will also be getting reflected. And we said that spherical mirrors are part of spheres. So if we take a part of this concave sphere, we are getting a concave mirror. Similarly, if we take a part of a convex sphere, we will be getting a convex mirror. Now let's consider a convex sphere in detail. Assume that this is a convex sphere and it's smooth and polished on the outside, so the reflections are taking place from the outer side. Consider this as a convex sphere with center C and radius R. It's rough on the inner side and smooth and polished on the outer side, so that reflection would be taking place from the outer side. Assume that these are two light rays incident on the outer surface of the sphere and they are parallel to the principal axis. Now these light rays would get reflected from the outer side. Now we said that a convex mirror is a part of a sphere. So if we take a part of the sphere, then we would be getting a convex mirror. And the radius of the sphere would become the radius of curvature and the center of the sphere would become the center of curvature. So we can define radius of curvature as the radius of the sphere of which the spherical mirror is a part. And we can define center of curvature as the center of the sphere of which the spherical mirror is a part. Let P be the pole of the mirror. Now if we trace these reflected rays backward, then they seem to be coming from a point F. This point F is known as the principal focus. So we can define principal focus as the point on the principal axis where the light rays traveling parallel to the principal axis after reflection appear to meet. So we said that a convex sphere becomes a convex mirror. Let's take the case of a concave mirror. Now in the case of a concave mirror, reflection would be taking place from the inner surface. So if we assume this as an incident light ray, that would be getting reflected from the inner surface of the sphere. Assume that this is a concave sphere. Now for a concave sphere, the inner surface would be smooth and polished and the outer surface would be rough. Let C be the center of the sphere and R be the radius of the sphere. So it is polished inside and rough outside, and reflection would be taking place from the inner side. Now if we take a part of the sphere, then that would become concave mirror. And in the case of a concave mirror, if we assume that there are light rays parallel to principal axis and incident on the concave mirror, incident on the inner surface of the concave mirror, then these light rays would get reflected and they would appear to meet at a point. Now this point where the light rays meet after reflection is called principal focus. So we can define principal focus as the point on the principal axis where the light rays traveling parallel to principal axis after reflection actually meet. Let's summarize the definitions for principal focus. Now for a convex mirror, the principal focus was defined as the point on the principal axis where the light rays traveling parallel to the principal axis after reflection appear to meet. And for a concave mirror, the principal focus is defined as the point on the principal axis where the light rays traveling parallel to the principal axis after reflection actually meet. Now the difference between both these definitions lies in this part. Here it is appear to meet and here it is actually meet. That's all about the basics of curved mirrors. Thank you for watching.